establish this is not a cult.
Yeah.
Something like announcing that completely unprompted.
Yes, definitely the reassuring words. Everything will be fine. I just realized that white background really lights up the room.
Yeah, well, I was going for maximum contrast because you never know how good.
Yeah. All right. So, hi everybody. Welcome to KW Lug. What is it? This is May. So we have two excellent presentations. We have Nathan is going to tell us about the IPFS, which is a distributed file system for storing stuff. There are many systems like it, but IPF seems to be the big popular one, and the one that's got lots of people behind it. And after the middle of the middle of the meeting, Doug is going to give us a update on Curve, which is his cult. His cult. That's a cult. As we repeated, we are not a cult. He is establishing a cult where you contemplate 3D objects and then create new ones.
Yeah, something like that.
I don't know. That's actually it's good cult material. Like,
Well, it's open source cult.
Yeah.
Best kind.
That's fine. All right. So coming up next month, we have a LaTeX presentation and a GDB presentation. So that will be interesting. Reminds me, I should probably make sure to post that to the C++ group. We do still need presentations for July and August, so if there's anything you're interested in, anything you want to present, or anything that you want to ask for, drop a message onto the mailing list, or put your hand up right now. Ah, weird. Yeah, as usual, that never works. Then in September, we already have a presentation that's a beginner AI machine learning thing. One of our members, Joan Curry, has gotten started on some courses, and she's going to show up what she's learned. I'm going to see if we can find someone who can do sort of the next level of like what you from the beginner present or she'll do the beginner stuff. We can see if we can find someone to do like sort of more advanced stuff. I know there's a lot of people around the region who do it, so see. So that's September. Then that for the future will still be presentation. So if you would like to present over the summer, drop a line to the mailing list, let us know. Other stuff. Something else to discuss in the mailing list. Bob selfishly mentioned maybe starting the meeting at 6:30. So if anybody has strong feelings one way or the other, we can discuss in the mailing list. I can prompt Bob to drop a message into the mailing list at some point. Let's see. So I think, if I remember correctly, we haven't actually talked about like time, any time, and like at all in the last couple of years. I think we talked about this a while ago, but it's been 7 o'clock for a good long time. So
Don't they lock the doors here around 7?
they do lock the doors.
So it might be nicer to let everyone in first.
That was part of the
There's
consideration.
one outside.
Perhaps we could also consider if people are not up for 6:30 a compromise of say 6:45 or 6:50.
If we want
if the goal is to get in before the doors lock,
I'm not sure.
you
how
don't need to win by a lot.
That's true, though I'm not sure how reliable door locking time is.
Well, as we saw today, the doors didn't actually lock because the sun's out. So
We can argue on the mailing list.
yes, so we can take it to the mailing list. Jason, correct me if I'm wrong. If I'm remembering bathroom part it that way,
Yep, right in the hall. You'll see they go there.
Right through the common room in the back.
right through the common in the back. And we usually go for dinner afterwards. I think the social is where we have gone, so I think that's the plan for tonight. A show of hands of people who will come along.
Probably.
All right, excellent.
See, it started at 6:30 to be easy.
Actually, that's true. There would be more places it wouldn't close by the time you get there.
Right.
So if you don't know where it is, the social is the thing that used to be the rum runner underneath the Walper Hotel, or just follow someone. There'll be people moseying in that direction. I think that's it. Does anybody have anything they would like to announce? All right. Without further ado, thank you, Nathan.
Okay. Hello, everyone. I'm Nathan Fish. just so you know, I've divided this talk into sort of loose chapters. So if you don't understand something on a slide, put your hand up right away. If you just have an additional question, wait a slide or two because it might be on the next slide. I'll be discussing the InterPlanetary file system, which is a pretty new open source project. So some background. There we go. A little slow. So pretty much the web pretty much runs entirely on HTTP. There are other protocols, but HTTP kind of runs everything. And its addressing scheme hasn't changed basically since the internet was invented. So we have a protocol name, which is at least a little bit upgradable. We can get HTTPS and so on. We have a website name, and then we have some arbitrarily long file paths. So this works, but the thing about SSL is that it doesn't refer to the type of content. All it does is say who you are talking to, which is a slight upgrade from IP addresses, which would be where you're talking to. So in order to have security, you need to have an SSL certificate, and the SSL certificate is bound entirely to identities. As some IT administrators in the crowd may know, it is annoying when you have many users accessing the same site over SSL, over the same thin link, and you can't cache any of it, because it's all encrypted data. Now some corporations put man-in-the-middle certs on their workstations and have a trusted firewall that does the caching and so on, but that has obvious problems. And so, say if kwlog.org were to disappear, or I preemptively wanted to make sure that it didn't disappear, I could try and download the whole site. But if I put that up on the internet again, I can't post it as kwlog.org because I don't have their SSL certificate. And even if I tell everyone, hey, I've got this mirror of the site now that it's down, they have no way of trusting that I didn't change everything. So SSL has some annoying problems in certain use cases. If we use content-based addressing, like IPFS does, we similarly have a protocol name, and then we have a hash. So this is the hash of all of the content. Because the content is linked to by its hash, we can cache it however we want. The user doesn't need to care where they're getting the data from. They don't need an SSL certificate to know if they're getting the right data, because if they trust the URL, they trust the content. They can just hash it when they get it. Similarly, if I want to mirror the site, all I have to do is run IPFS pin, which essentially means download all of this and set it to never be dropped from cache. And now I'm mirroring the site forever, and no one even needs to know that I'm doing that if they don't pay attention. The site just keeps working. So IPFS defines a format, content identifiers, or SIDs, which was intended to be a universal format for anything that you can feasibly address by hash, which, to be honest, is most things. The original hash, they weren't really thinking of it being universal, and it's been retroactively named SID version 0, and it's just a base 58 hash. SID v1 does all sorts of cool things. You can specify the base, so you can have shorter hashes, or longer hashes that, say, don't have zeros and O's at the same time, or are all lowercase in case they get mangled. They don't have special characters, things like that. The SID version, a content type, so the URL actually defines the type of thing that it points to, which is pretty neat. And then a multi-hash format, which is basically a nesting of the same sort of structure of type of hash, how many bits of the hash, and then the hash. So you can, within the SID structure, you can upgrade your hashes backwards compatible. The string itself that the user can copy and paste tells them what kind of hash this is supposed to be, has all the content you need to read it, which is quite clever. In order to find content, IPFS is a peer-to-peer network. So you have a URL, you need to find where this data is that you have a hash to, because we moved to content-based addressing. There are no, the hashes don't point to servers anymore, right? URLs don't point to servers. So some of you might be familiar with distributed hash tables. BitTorrent uses them, lots of other peer-to-peer networks use them. The basic, I will be explaining the sort of naive distributed hash table here. All of the ones that people use in production have much more fancy features and optimizations and things that I won't talk about, but this is the basic idea. As a peer in the network, we need to be able to both find what peer has something quickly, and then find out the IP address of that peer so we can talk to them. And both of those can be thought of as a key value lookup. So every peer has an ID. In the case of IPFS, that's the hash of your peer's public key. So we have some bit string which is fairly evenly distributed and cannot easily be faked. We remember all of the addresses of peers that are very close to our ID with essentially an exponential curve. So for example, we might keep all 4 peers that share all of the last 2 bits of our address with us, and 4 that share only the next 2 bits, and so on and so on. And so we have only a few peers that have completely different addresses than us in a nice curve. So if you want to look someone up, all you have to do is look at the hash you're trying to look up, see who the closest couple peers are that you know of to that address, and ask them. And they will probably tell you, no, I don't have that content, but this guy is who's in my storage is closer, and so on. And you end up getting log n lookups. So with 1 million nodes in a network, worst case ends up being something like 7 hops to find the exact node you're looking for out of the million, depending on how you do it. So when an IPFS node starts up, all it has to do is do a put to the network, which does the same sort of resolve, contact peers that have similar IDs to me, and tell them that my peer ID is at this IP address. And IPFS uses this particular ultra backwards and future compatible format for things like they do for everything. They are really good at thinking ahead. So this is just IP4, an address, over TCP at port 4001, which is the default port.
I have a question.
Mm-hmm.
By closest peer, you mean location-based?
No, sorry, this is ID. So our ID, exclusive or their ID, gives us a number, which is essentially the same as subtracting the 2 and taking the absolute. And that's the distance function.
But you said the IDs are hashes, yeah?
Yes.
So how my ID is generated?
So
Hashes what?
on first start, if your node hasn't run before, it generates a new key pair, and then it hashes its public key, and that's its node peer ID.
But
So-
then, a peer with the closest hash could be in China.
Yes.
So what's the efficiency here? I mean, you have a distance
Yeah.
that's against you, yeah?
So it's not so much about geographic distance, it's about making it very easy to know who to look for. There are optimizations. There's like I said, this is the naive version. There's a better DHT called Coral that does some cool weighting by geographic distance and latency of links and all sorts of cool things. And IPFS is constantly iterating on their DHT and making it faster and faster. But like I said, there's a ton of optimizations you can do with this that make it much more complicated, and I'm just discussing the naive, original DHT idea white paper sort of thing. Does that make sense?
Yeah, one more with 2 slides back. You have base 58. Any reason for using that?
Yeah, so it's basically lowercase letters, uppercase letters, and digits, except not using O's because they can be confused with zeros, or the other way around, I forget. Not using L's and I's, things like that. So it's basically all the characters except a few that people confuse. Bitcoin also uses base 58 for Bitcoin addresses. It seems odd, it's like 58, but it's basically how much data can you pack in here that someone can look at and reasonably type without making a mistake. So it works.
And with this multi-hashes of what in the B1?
So that's the hash of the content.
Multi-hash, that means you hash it multiple times?
No, multi-hash it's actually much like this format. It's a self-describing future-proof hash format. So it's just, so right now it's take the SHA-256 of the content and then append a little header that says this is SHA-256 and there follows 256 bits. That's all it is. So if you change later, you could change it to SHA-512, and it would still be SID-V1 compatible, and you don't have to change anything here because the multi-hash says this is SHA-512, here follows 512 bits, and then the hash.
So you are not hashing multiple times, yeah?
No,
Oh, okay.
it's multi-hash as in it is a self-describing format that lets you use different hashes and upgrade them for future proofing while always having a header declaring what kind of hash this is so you can parse it properly. They've put a lot of effort into making sure that things are very future-proof.
Because Bitcoin uses multiple SHA-256 that
Two
applies
rounds.
twice
Yeah.
when it generates the public address.
Yeah, just in case. But yeah, this is format rather than a iteration time. Yeah, so your node starts up. It does a put. This is essentially an announce to the network. But it contacts the peers that have peer IDs similar to itself, because it's always the peers whose ID is similar to the key. And in this case, the peers are peer ID. So you look up in your existing peers. The config file, of course, comes with a list of bootstrap peers that tend to have high uptime so that you can get counted quickly. But you can change those out if you want. And so we contact the peers that are have similar keys to us, which, as mentioned, could be anywhere in the world, and tell them that the key, our peer ID hash, it resolves to that string. In this case, that's a local IP. It's actually a list of IPs. It's every IP that we have, multiple ports we might be listening on, TCP and UDP versions, etc. But for simplicity's sake, just that one. And then every time we add a new object, or our node is starting up again after a long time and wants to refresh everyone's memory that we still have this object, we do a similar put call with the SID of the object and resolving to our peer ID. So this peer has this content. And so that, because the key is the object SID, that will be stored on nodes that have IDs similar to the object's ID, as well as ourselves, because we're the one hosting it. So we might as well. And so when you want to find an object, it just does the same thing in reverse. You do a get for the object SID, you get back a list of peers that have recently said that they have this. Then you do lookups on their addresses if you don't already have them, and you get that address back, and then you issue a connect to them. And then there's the next sub-protocol of IPFS called BitSwap. This is very similar to BitTorrent. It's inspired closely by BitTorrent, but also a number of other clever innovations that have come since. So as soon as we connect to a peer, and this is anytime you connect to a peer, whether that's because you think they have something you want, or because you just boot up and you're just trying to hit your 400 peers that you want to have for optimal performance or whatever, we both immediately send a want list of all of the object SIDs that we want and don't have, although it's capped at some 64 or something like that, so you don't work people. And then the other side, without any particular acknowledgement, just opens a new stream and starts sending us one of those SIDs if it has it. The current IPFS transport has multiple logical connections multiplexed over a single actual TCP or UDP connection. So all your, I forget the name of the protocol, sorry, but it just starts throwing the data at us as soon as we say that we want it. As soon as they close the connection, we hash it. If it matches something in our list, we save it, otherwise we throw it away. And we keep a ledger of how many kilobytes we've sent to them and how many kilobytes of data that we've received, ignoring anything that didn't hash correctly because that's not any use to us. And then we prioritize requests from peers that have been helpful to us, thus incentivizing people to be helpful. That's chapter 1. Questions? I might have gone kind of fast. Yes?
How can you monitor what you said is happening?
Like requests that are coming to you and that you're
Yeah,
serving?
the want list, and can you see that with
So you can see your
Wireshark?
own want list very easily. Just run IPFS BitSwap want list and it prints your want list.
Oh.
You can type a peer ID after that and it will show you somebody else's want list that you're connected to. I don't think there's a way to say what am I currently sending or anything like that, or how many times has this object been downloaded from me. I think that's a requested feature that's somewhere way down on the priority list. That would be nice though.
If you put Wireshark, can you see something?
You could, yeah. Although there's a number of layers to the protocol, so it might not be easy. It uses some fun libraries to speed things up. Yeah.
So at the beginning you described this as an alternative to HTTPS. So in terms of like performance and latency considerations, how does this compare?
So
in practice
across a single link, like if you're talking about, you know, A2B over HTTPS, A2B over IPFS, currently it's slow because it's new and people put a ton of work into making HTTPS and web services browsers and stuff fast. IPFS is fairly new. But if you're on, say, this campus network and someone else near you has already downloaded this thing and the server's in China, it's probably going to be faster, right? And the point is, you know, the implementation efficiency, the details of the code are getting faster and faster. Currently, they're nowhere near the optimization levels that Apache is at. But just doing less things, getting data from people that are close to you instead of having to go to the original source every time, all those sorts of network level efficiencies are kind of the point.
Yeah.
And so currently, there's only some use cases where it's faster, but as the code gets faster, that should increase.
So this is probably covered, this might be covered later, but I'm just wondering, I'd like to at some point hear about like what are the realistic use cases, because I don't think this really covers everything that you can use the web for, right?
Yeah. So
like this is really only, realistically you're only going to find popular files. You're not going to find something that somebody, you know, put on GeoCities and then, you know, whatever, 50 years ago, whatever that is.
well, actually, if anyone decides that they'd rather like this website to be on IPFS, and at least one node stays online with it, then you will find that. As long as you have the link to it. Of course, the IPFS link is different than the website link, so that might not be easy to find at first. But for example, the jargon file, some of you may be familiar with, old website with all sorts of cool hacker culture history.
That would be an example of a popular file.
Right. So they issued a tarball on their website to mirror it with. I downloaded it, did IPFS add. I'd work at home. Now it's on IPFS. And if anyone else, the neat thing is that if anyone else does exactly the same thing, they will get the same hash and they'll be mirroring it for me and vice versa. So on my work computer and my home computer, it was actually faster to just download the tarball in both places and do an IPFS add in both places, rather than using any IPFS commands to mirror it across. There's my own internet for that. Yeah. Anything else? No? Okay. So if you could just upload single blogs, that wouldn't be too helpful. Instead, we have a directed acyclic graph, which is a needlessly fancy term that computer science likes for a graph, so like a tree, that links are one directional, and it's impossible to have a loop. And this kind of happens automatically because we refer to objects can refer to other objects by their hash, which is a one-directional link. Parent has a link to child, child cannot have a link to parent because then its hash would change and would work. So we have anything we can construct anything that we can refer to as a hierarchy, which is basically any kind of data. You can do directories, Git repositories, basically anything. For example, if you do a raw object get on a directory rather than downloading it as a file, you just say cat the raw IPFS block with this command. This is what you get. It's essentially a JSON object, and it's just a list of dictionaries where each dictionary is a file. So logo.svg is an arbitrary file name which points to a hash, and that's how in the earlier URL I was able to have IPFS/hash/ logo.svg. This hash is of so the hash that's on the screen here is the hash of KWLog's logo from their website. But this directory will, of course, have a different hash, and you can have an arbitrarily large directory tree that has as its root a single hash, and have whatever user-friendly file names you have within that, which is how you can get functioning websites. You can, on a similar note, you can mount IPFS. It's obviously a read-only mount, because file names are hashes. And you can't go to /IPFS and type ls. It says permission denied, because that doesn't make sense. You don't know what keys are in the network. You have to look for one specifically. You can't just say copy everything. But you can just cd to an arbitrary hash if it's a directory, or ls it, and you see the file with its contents and everything. Pretty cool. There's also an HTTP gateway, which is probably better for most use cases. So this is how you can have functioning websites. The browser has a plugin that redirects to your catches IPFS URLs and redirects them to localhost, so that your IPFS daemon can answer them. And you have whole websites that you can download things from in your browser. Content-based addressing makes IPFS 100% Ethernet compatible. I was mentioning earlier, if you have a partitioned network, you have some network that has no internet access or has really slow internet access, or may as well. All you have to do is IPFS get anything arbitrarily large site on one machine, put it on a USB stick, bring it to the other network, do IPFS add. And as long as the other person didn't use any unusual features in uploading theirs, it will get exactly the same hash, and all of a sudden all those links start working on this side of the network that's not connected to the internet. You get deduplication. Two people upload two objects, or one person unknowingly uploads the same file twice, it gets the same hash, it gets stored once. Two people upload the same thing in two different places. They can now pull that link from each other because it's the same link. So if one of them loses it, you just have to click the link again, it'll be caching it again. Every time you download something, it becomes cached on your node until it gets kind of kicked out of cache eventually. So the more popular something becomes, the faster and more resistant to denial of service it becomes. Questions? Yes, Paul?
Sort of many, but here's one. So if I rename a file, it's got a different hash.
No, so the file itself has a hash. And then there's a directory, which is an object that says this hash has this file name. So if you rename the file will have the same hash, but the directory containing it will have a different hash. And now there will be two directories out there, both containing the same file, duplicated, but under different file names, and they will have two different hashes.
And then secondly, all this talk about hashing. So let's say I want a file. I want Doug's curve file. I don't know the hash of that.
Well, in order to
How do
fetch
I get
anything,
that?
you have to have some sort of URL, right? I mean, if Doug has to have a website for you to download this from, or some URL for you to find it, right, across the normal internet. So you have to get a URL out the way. In this case, the URL is just a little long.
I think,
Tim?
I could be wrong, but just to expand all your confusion, essentially, like, URLs have a discoverability. I can discover hashes, don't get me wrong, they probably won't point at anything, but I can discover them. And so, like, how does this file system help users discover the content they want? Like, what's the next
it's
file?
no different than the internet. I mean, you go to someone's website and it has links to things. Somebody has to tell you some URL somewhere, even if it's a search engine, in order to find something. You have to get a pointer from somewhere else. What was that?
Did we try to discover the URL in 1991?
I have not. It's not really fundamentally different than the normal internet. I mean, okay, Google does a much better job of indexing the internet than IPFS currently has tools for, but it's just a different URL scheme.
In 1995, I bought a book that had all the URLs.
Yeah, good luck printing that today. By the time you were done printing, you have to print another volume. Yeah.
So, if you wanted a user to be able to use IPFS URLs from within their unmodified web browser without downloading and installing any software, has anybody tried to make that work?
Yes, so the main IPFS daemon is really good, but there is a side project, JS IPFS, which is written entirely in JavaScript, and which you can ship to a user in their browser and essentially bootstrap your own CDN on their browser, which is fairly clever. So you have some website that contains nothing but a little bit of dynamic content possibly, and the JS IPFS. A user contacts that, downloads it into their browser starts up an IPFS node, starts peering, and starts downloading all the static content from all over the world.
Cool.
This has been done.
Okay.
It's a little resource intensive at the moment, but it can be done.
Well, I'm sure if they just compile it into WebAssembly, all problems will be solved. So, yeah, okay, cool.
But yes, that is a thing.
Yeah.
JS IPFS is an active project. It's usually about kind of one major release behind Go IPFS in terms of features, but it has all the core features and it does work. I haven't really tinkered with it myself, but yeah, it's pretty cool for bootstrapping.
I mean, you'd probably want, like, in order for this to be like popular, like, you know, like something that's for more than members of KW Plug type of audience, you'd want to have like Firefox to like, you know, incorporate the software and,
Yeah.
you know, and have, you know, somebody.
Yeah, so right now you just have to download a plugin from the Firefox store.
Yeah.
But if this becomes even slightly popular, Firefox can just integrate it. And
Yeah.
then it would work.
So obviously, you know, some form of Google for discovering IPFS URLs would be desired, but we wouldn't want Google to do that. We would want to have some kind of anarchistic, distributed, decentralized
Yes,
system.
and that is a very interesting problem.
Yes. Okay.
There is a search engine called Yasi that is not made for IPFS, but is made to be a distributed search engine. They might have some thoughts about that. I haven't checked it.
Okay.
Yes?
But there is a risk that the content that's not popular might disappear because the hosting of the file is by peer willingly to host it, yeah? So if the
Right.
peer goes offline and you go offline and you have only these two locations, the content is gone, yeah?
Yeah, but this is upgrading from a model where there can only be one peer without a great deal of effort, right? So something like the jargon file or some dude's random website where he posted this really good guide on how to get this weird thing with an Arduino to work, and then it disappears. And we do have the Internet Archive, but that's a single location with limited resources and only snapshots things every so often. So if it's an IPFS website, with the browser plugin, in fact, you can be on the website and say, this is cool, right-click, pin, and keep browsing. And your site will recursively download everything and pin everything, which is essentially just set to never expire from cache. And then you'll be running that website forever.
But then the hosting, it's still, someone has to host it, yeah?
Yeah,
If
I
you
mean,
go
you can't get away from
offline,
needing network and storage somewhere.
so there is no like free IPFS hosting that's hosting everything, yeah?
No, it's a decentralized network. There are pinning services where you can pay people to pin stuff on high bandwidth servers and so on. But those are kind of dangerously centralized, at least the major ones. There was actually some discussion I was involved with about setting up kind of groups of acquaintances who agreed to mutually pin some amount of each other's data. You know, 1 gig from everyone, everywhere, and then you have 8 copies of everything and everyone's happy. That's kind of a neat system.
Are there sites that you pay to have content hosted?
Yes.
Okay.
Other questions? Yeah?
Are there access controls?
Such as? Like who can go to a URL?
Yeah.
Encrypted. Pretty much. I mean,
What does that mean?
like it's a URL that points to data. If you only want some people having access to data, then encrypt it. That's basically it. I mean, so you can have, you can encrypt your file, upload it, it will naturally get a different hash if it's encrypted. And then only people have to have the URL, but also have the key to it. That's encryption is really the only way to implement access controls in a decentralized network where you're having other people cache stuff for you. Yeah, that's kind of how it works. There is a system called the mutable file system, which implements a read-write file system on top of IPFS, which I haven't looked into in a ton of detail. I think it's still fairly slow, but it does work pretty cool. And you can, I think, have people with read or read-write permissions for that. But that's like a whole layer of cleverness on top of IPFS rather than something in the base protocol. Andrew?
Extent of that, has anyone, would that possibly encrypt? Has anyone started to like build a system that do that using like public kind of stuff?
Yes. I can't remember the name of it now, but there is a very cool Git repository that is working on a system to have so a mutable file system and websites and all sorts of stuff with like a user-friendly interface for granting people non-read, read-write, sub-grantable permissions, and so on in some user-friendly way, which is still fairly new, but I think quite an active project and is getting somewhere. So if you did want to implement a distributed file system between multiple people where some people had read access and some people had read-write access, it would abstract away the details of key management and all sorts of, well, sub-key management at least. Everyone would have to have one, but you can have the software take care of all the arbitrary key stages of every block and stuff under that for you. Sorry, I can't remember the name of that right now. I have it started on the web, so I should be able to find it eventually. Other questions?
Private IPFS, like an enterprise, so you don't make it like a consortium, like there
So
are.
like a partitioned network, not connected to the rest of the global
Yeah.
network. Yeah, you edit the config file to only have your own peers as bootstrap peers, instead of the 8 default ones that come in the config file. And I believe there is a setting that you can set a shared key that they all have to talk to each other. And then you have a separate swarm. Essentially, IPFS put a separate namespace that won't connect to each other unless you change the rules. So that has been done. Actually, one of the use cases that IPFS has been used for in production, or at least testing for production, is moving Kubernetes images around in a data center. Because they need to suddenly be available in arbitrary places in the data center, sometimes with little warning, and you want a decentralized system, and you want it to automatically scale with, if you said spin up 5 of these, you might want 5 machines caching it. If you say spin up 1,000 of these, you want lots of machines caching it, because this is about to pull many, many times over. And so people are actually using IPFS to download Kubernetes images around and between their data centers.
So that's really cool. I had a question about Cloudflare's interface, but first, before we go too far off that, I think Uber just released something that uses BitTorrent in the stack for container distribution.
Kraken.
It's called Kraken. Yeah.
Oh, yeah.
And
As in the K Kraken.
Yeah, I assume so.
not to be mistaken for the Git Kraken, or the Drink Kraken. And Cloudflare interface, have you touched on that? Do you know anything about it? Because they have an IPFS front end. That can
Yeah, so
interfacing.
like I was saying, there's an HTTP gateway that's part of the daemon, and IPFS.io runs one. Cloudflare also runs one. I forget the exact URL. I'm sure it's in time. And lots of other people run one too. So the thing with the gateway is this is chaining between the internet and IPFS. So when you give them a hash, you are trusting that they are going to, their daemon is going to get the correct hash, verify it, not tamper with it, and pass it on to you over SSL. Of course, you could download it and then hash it yourself and read the multi-hash, but I don't think there's you would have to do an IPFS ad yourself to test it would be the easiest way, in which case, why are you using the public gateway? But anyway, so you are trusting them to download stuff to you, but the Cloudflare gateway is definitely probably one of the fastest gateways out there, because the Cloudflare. Yeah, and there's a whole bunch of other gateways, but IPFS.io and Cloudflare are the ones that have uptime and reliability and stuff. Yeah.
So these caches, they smell like they grow forever.
Well, there's a cap in the config file, and it's at least recently used cache.
Okay.
So the default, I think, is 10 gigs of cache, but like it's just an integer in the config file, right?
And can you
I crank
apply
mine up.
policies to things? Like, can you say, I want this for 5 minutes because it's just the sports scores, or I want this thing forever?
So currently there's only normal and pin, which has never grown. Fancier policies are doubtless on the to-do list, but for the moment it's everything you request gets cached, and then you can say IPFS pin, and that just sets a bit on it, so you never don't miss it. So that's if you want to host something intentionally, right, and say I always want to be running this site where this is my blog, I always want to be serving it, then you just say pin. And if you do IPFS add on a file, it automatically pins it unless you pass a flag otherwise, because that doesn't make sense.
So just by that, it sounds like IPFS normal would like maybe call old.
Yeah, so it's
things
least
if you
recently
have
used
that.
cache-ish that basically whenever you hit 95%, it does, right now is whenever you hit a 95%, it does a single massive garbage collect. But they're working on turning it into a more continuous, smooth, least recently used cache with fancier cache features. As we all know, cache validation is one of the hard problem. But,
Yeah. Is there a standard or quasi-standard, I don't know, URL shortening service or a system for making pretty easy to remember URLs for?
so there is some DNS integration where you can have someone go to a URL through DNS, and therefore you can register, which links to an IPFS server.
Okay.
And that's also very fast.
Yes. Okay, that works. Yeah.
Now, you do have a dependency on them having functional DNS and hopefully DNSSEC and so on, but it does completely solve the remote URL bit.
All right.
Again, I'm sure people are working on even more distributed, fancier systems for this. Paul?
So, somebody takes incriminating pictures of me using Windows, and they upload it to IPFS, and let's pretend we're in a world where a court or something can say that shouldn't exist on the internet. Is that incompatible with IPFS? Can you get rid of things?
You can't force delete other people's stuff over the network, obviously. Currently, IPFS is not anonymous. It's intended that eventually, once other problems have been solved, you can just run it over Tor. Unix philosophy, use tools for their own purpose. If someone is hosting something that you don't want them to be, and you know the hash of it, you can look up quite simply in manual command line who says they have this, and then go kick the door down, I suppose. Physical access is really good. But yeah. But there is obviously no built-in way to say, stop having that, as with any other system. But yeah, I mean, if you can track people down to a physical location and you have people who comes on your site, you can do whatever you want. Yeah.
I want to just make a comment that IPFS is used in blockchain like Bitcoin or Ethereum to store content, because storing directly on the blockchain is very expensive. So people use IPFS, they take the hash and they store the hash in the blockchain.
Yeah.
That points to the content, so that way.
Yeah, and then the blockchain unambiguously says this content, but does not contain it, because that would force everyone to store it and everyone to connect to it.
So with that sort of thing, and I'm actually working with library.io to do a similar solution currently, I believe with BitTorrent currently, they're trying to adopt IPFS, but they want to modify the
Oh yeah, cool.
protocol.
You said library.io?
LBRY.io.
Oh, okay, that sounds familiar.
Yeah. It's a content distribution platform. But anyway, so the way it still is, you still have to manually fetch those files. So you unless somebody else has acknowledged its existence or is automatically pinning new content or getting new content as it's the network.
You mean like from outside IPFS to inside, or?
Even inside. So like if there's only one person who's fetched it, from what I understand, it doesn't just like automatically distribute, right?
No, so it's not like, say, Freenet, where people along the path that you fetch it from start caching it. You fetch what you request.
Yeah.
So no one ever puts things on your machine, which is generally a good thing in most people's minds. Though Freenet model is quite clever in its own way. But yeah, so if you want it to be hosted somewhere other than you, but other people don't want to fetch it because it's, say, your backups, then you'll just have to get a friend or someone that you pay to pin it for you. And yeah, me and some acquaintances on the IRC channel were discussing having a system where, say 8 of us say, okay, each of us is going to have a gig of stuff, and we're all going to pin each other's stuff, and we all have 16 gigs of, 8 gigs of space because we all have 8 gigs of space, and everybody's happy. We haven't gone around quite doing that yet. That's a system that, if you have lots of friends who use IPFS, you can quite easily do that sort of thing. Other questions before I move on? Yeah, well, I didn't think I would get all the way through this. That's part of the reason I had new chapters. Okay, so if you want to have a website, it kind of helps to be able to change it. So if you just have pure content address storage, then you would have a totally new website every time, totally new URL every time you change your website, which is not very convenient. So we have the InterPlanetary naming system, which operates on a model quite similar to Git, mutable references to immutable data. So you have an IPNS link, I've highlighted it in color for you because it's not immediately obvious. And that is also a hash, but it's a hash of a public key. And what that means is not fetch this file, it's look up the most recent IPNS record signed by this key, find out what IPFS link it points to, and download that. So it's similar to a DNS system. So you, by default, if you don't specify the key argument there, it just uses your peer ID. But for a lot of things, it probably makes more sense to make a named key for the blog or whatever it is you're publishing. And then you just say, use the key called blog, and say that this IPFS hash is the latest version of my site. And it does that. And then you get an IPNS link back. And anything you sign with that key blog will have that same IPNS hash, but can point to updated versions of content as you go on. That just resolves right back to the same thing. And you have, quite similar to DNS, you have TTLs. So you can say, this record has a 15-minute TTL. If someone looks it up and they downloaded this into their cache less than 15 minutes ago, don't do another fetch, just assume this is still correct. You also have a lifetime, which is separate, which is, so say you do a lookup and it's not within TTL, so you have to fetch it again. Lifetime says if it's been more than X time since this record was published, don't try to resolve it, just say it doesn't work. So you can, by default, there's no lifetime. So it's just the newest record I can find, however old that might be, just try and make it work. But for certain types of content, you could say, if this is older than 24 hours, people don't want it, just stop. Depending on what you're doing. There's also a DNS link, which is a clever thing that the browser plugins and the game can do. So you use DNS, because IPNS is still a bit slow, and it doesn't have the readable URLs. You can have a DNS TXT record, which is basically a user-specified data field you put strings in. And it just says DNS link equals IPFS hash. And so when people go to that site, because the TXT record isn't normally read by a browser, it's for special purposes, you can, for example, IPFS.io, the main website, if you go there, your browser right now, you get the site normally over HTTPS. If you have the IPFS plugin installed, it reads the DNS link, redirects to localhost if the plugin is currently connected to a live game on localhost, and loads the site over IPFS, and it works exactly the same way, which is pretty neat. And I pinned the entire IPFS website in 5 minutes because I felt like it. And now I'm hosting IPFS now. Questions on IPNS? No, just the root hash. So if you have a file directory, just the top directory's hash, and then everything else can just be human readable file names after that. Right? I can ask questions. How am I doing for time? Do I have to stop now?
5 minutes.
Okay. So, actual use. There's a bunch of different ways to install it. There is a snap package, but it doesn't let you edit the config file and puts things in weird places. I don't like snap. Nix, as was mentioned last month, Nix is an excellent package manager, and there's a nice IPFS package that is very up to date. You can also go to their Git repository and do a go get and make install, and it will work. Get the latest dev version. And then you just do IPFS init, which creates a data directory and an empty data store and a key pair and a config file and all that sort of thing. And then IPFS daemon starts up the daemon. Install the IPFS companion in Firefox or Chrome so that your browser knows how to understand IPFS links and will redirect to localhost. You can set it to not be localhost. I have mine set to go to my home server because it's better uptime than my computer. And then you can visit IPFS.io and it should think for a second and then go to localhost and download it over IPFS. It has some limitations. That is annoying. It's a peer-to-peer network. That is annoying for all peer-to-peer networks. IPv6 solves this entire problem and is great. It's a bit of work to set up, but especially if you want to have multiple nodes on the same network, it simplifies things immensely. IPFS is not at all anonymous. It works entirely on announcing to everyone what you have so that they can get it. It should be possible in the future to run it over Tor, but it's not really approved to do that yet, because for the same reason as you should run BitTorrent over Tor or lots of other things over Tor, because it's a peer-to-peer network and it likes to announce its IP addresses everywhere. So it doesn't really work properly. IPNS resolutions are currently kind of slow. The last two major releases have had major improvements, but it's still kind of slow. But it's moving quickly. And I have some more stuff on extra features of IPFS, but I think I should stop because I'm pretty important stuff. Questions? Last round of questions. Here I was worried for like 40 minutes. No questions? Okay, I guess I'm done then.